discuss about 3 and quad 3.
Hello, sir. I'm Ariane Esmada. Today I will discuss about 3 and quad 3.
A 3 in computer science is a data structure composed of nodes connected by pages. It's a hierarchical structure where each node has a parent-child relationship. These are widely used in algorithms and data structure for organizing retrieving data efficiently. In kung pag-aaral na kung sa computer science na data structure composed of nodes and pages. Ini kung nalilisi na iwain sa book ni magandang sa pag-usalo ng algorithm iba data structure para ma-organize sa data sa mga mabilis so para mabilis parts. Ang isa organize ng retrieving data efficiently. Matubagay papasa na sa pamamagitan ng computer sa ito mga so pamamagitan sa limit. Quad 3 is a specific type of data. Data structure used to partition a two-dimensional space. It's particularly useful in application involving spatial data like geographic information system, image processing, and computer graphics. In a quad, each node can have up to 4 children, hence the name quad 3. In quad sa pag-aaral, specify sa type of data structure use partition, a two-dimensional space. Ang mga pagtawag na example niya, geographic information system, image processing, computer graphics. Computer graphics ay mag-design kita, mag-calculate. Ito sa mga sa computer graphics like mga mag-design, calculate na rules. It recursively divides a space into quadrant until a certain condition is met, like a threshold number of points or minimum size of quadrant. This allows for measure, querying, and manipulation of spatial data as it enables operation like range research, neighbor research in algorithm type complexity. What are the importance of 3 and quad 3? Ano naman lang na yung mga importance of 3 was quad 3. 3 and quad 3 are important data structure in computer science and various application. Like, at least in important application like hierarchical data representation. These are used to represent hierarchical relationship like file system, organizational chart, example, etc. In hierarchical data representation, pagpapasang po sa mga like pamagtawag kita sa file class, mga file manager, mga organizational chart, mas mga bulletin board, mas mga HTML. Another importance of phrase, repetition, searching, and retrieval. Binary search trees and balanced binary search trees. Allowed for repetition, searching, insertion, and deletion operation. In efficiency, searching, and retrieval pagkain, kasi meron tayo na magkita sa pamamagitan file, mga computer sa design build, sa mga iOS, on sila ni tawag sa delete na pagkano. Sorting trees can be used in sorting algorithm like fit search. Routing algorithm, trees are used in routing algorithm like try data structure analysis and heavy routing tables. Ang routing algorithms mo pagkano sa pamamagkausan sa mga piso wifi o sa router to router apply sa IP address. We'll say symbol tables. This can be used to implement symbol tables which are fundamental in compiler in symbol tables, mag-usal sa symbol tables. Tapos mga mag-code kita, ito mag-usal ng mga symbol, mga question mark. Importance of quad trees. Spatial data partitioning. Quad trees are used to partition two-dimensional space efficiently. 3. They are crucial in application dealing with spatial data such as geographic information system, image processing, and graphics. So pagbasa mo sa spatial data as part of what is mag-post sa mga two-dimensional space based pa kayo na geographic information system, image processing, and graphics. Mag-post sa mga design na ginagawa Range square queries. Quad-trees facilitate detection. Range queries which involve finding polypoints or object within specific region. Nearest neighbor searches. They allow for finding the closest object to given point which valuable in application like proximity searches or map database. Yung nearest neighbor search yun, sa pamahay ng mga Google Map. Malapit na yung best routes para na-detect na kalagay. Collision detection. Quadrants are used in basic engine or games simulated physics to detect collision between objects into this space.
Now we will talk about the quadrics and disadvantages of quadrics. Okay, what are quadrics for? Quadrics are used in image compression where each node contains the average color of each cell with the different quadrics in the tree. The more the detail of the image, quadrics are also used in searching for nodes in a two-dimensional. So, advantage of quadrics. Efficient and next thing. Efficient partitioning quadrics excels at dividing in a two-dimensional space in smaller region. It is particularly used for spatial analyzing and searching in applications such as computer graphics and geographic information system.
Go.
So, ibig in is efficient spatial daw ay tumutukoy sa paggamit ng mga teknik at algorithm upang organize at mahanap ang mabilis ang mga spatial na datos ito ay karaniwang ginagamit sa mga sistema ng database at geographic information system. Number 2, dynamic data insertion. Quadri allows for efficient insertion and deletion of data points within a special region. Dynamically adjust the tree structures to maintain the appropriate subdivision as the data changes. Ito ay isang konsepto sa programa ng pagpapatuloy sa mga datos na pagbago o pagkaroon ng mga pagbabago sa oras ng pagpapatak ng isang programa. Ito ay isang uri ng data structure na kasiguran maaaring baguhin o i-update habang nasa green squares. Quadrics in application green squares that involve searching for points or object within a specified rectangular region. It reduces the search space by traversing on the relevant quadrants, leading to improve query performance. So green square is maaaring nagdagdag ng data ng mga elemento sa loob ng datos sa program na sa pagkakalibaw ng mga dynamics na nag-awin as list at binary search tree. Back representation. Quadric can represent sparse data by using favor nodes and subdivision in region with favor points. These compact representations reduce memory usage and speed up the result. Disadvantages of quadric. Number 1, memory overhead. Quadric can consume significant memory, especially for large data set or when the data points are highly concentrated in a small areas due to the recursive nature of the tree, which requires the allocation of nodes for each subdivision.
Good afternoon. I am Husseina Ajmadudan, and today I am going to tackle about the quadri and octree. A quadri is a three-data structure in which each internal node has exactly 4 children. Quadris are the two-dimensional analog properties and are most often used to partition a two-dimensional space by recursively subdividing into 4 quadrant regions. An octree is a 3-base data structure used to partition 3-dimensional space. It is similar to a binary tree but extends the concept of 8 children per node, corresponding to the 8 structure used to three-dimension space. In it, it's similar to binary tree, but extend the concept. Here are few definitions related to trees. 1. Octane, a cubic region of space that is represented by a node in the octave data structure. Each octane divided into 8 smaller octane. Octane is represented by a node in the octave data structure. And it is divided into 8 smaller octanes. Number 2. Node. Each node is an octane represents an octane of space. It contains information about the contents of the octanes and represent to each child nodes. Node is the contains information of octane and represent it to each child nodes. 3. Subdivision. The process of dividing an octane into 8 smaller octane. This recursive subdivision continues until a termination condition is met. Subdivision is dividing an octane into 8 smaller octanes. Number 4. Left node. A left node is a node in the octaves that does not have any children. It represents a small subdivision of space and typically contains specific data or object within that region. The left node is the octave that does not have any children. Number 5. The depth of an octave refers to the level of subdivision. The root node is a deep 0 in each subsequent level of subdivision. Increase the depth by 1. The depth is an root node in a deep 0 in each subsequent level of subdivision. Number 6. Spatial partitioning. Octaves are commonly used for splitting partitioning, which involve dividing space into smaller regions to efficiently organize and query data. This is particularly useful for applications such as collision detection, rendering, or spatial indexing. Overall, octaves provide a hierarchical representation of three-dimensional space, enabling efficient storage, retrieval, and manipulation of spatial data. The octave data structure offers several advantages.
Assalamualaikum, my name is Cesar Suntalunga to discuss about advantage of octave. It is special partitioning says at dividing three-dimensional space into smaller regions, in particular is coordinates. Sa kaso ng computer graphics, yung data representation and manipulation detection that include 3D spatial data. Number 2, dynamic data insertion of layers or efficient insertion and manipulation of data points within the three-dimensional space in usually adjust the phase structure to maintain the repeat subdivision as data change. The range perspective and representation range that insertion or points or object within space by volume or bounding box. Reduce the search space by focusing on the relevant contents, leading to improved performance. For compact representation of efficient sparse data by using the nodes in subdivision in regions. Points this compact representation reduce memory usage in space of the result. Disadvantage of octave: memory overhead, retain, consume significant memory, especially for large data or when the data points are highly concentric and small volume. Is due to sort nature of the tree, which require the division of nodes for each subdivision. Performance for point-based 1236 traits its performance mitigate for point-based search where individual points need to be accessed by establishing the tree to locate specific point can be less efficient compared to other data structure optimized for direct access. Subdivisions, the subdivision of the space is based on the distribution of data points. If the points are distributed, may result in planned subdivisions and essentially impact performance. Performance can be affected by change the distribution of data points. If data's distribution becomes highly irregular, it may increase supplemental decrease structure and decrease efficiency. As with any spatial data structure, it is important to consider the specific requirements and characteristics of your application when deciding to use Innotree or any other data structure.
Assalamualaikum, my name is Marquisa Ibrahim. The difference of quad-tree and octree. The main difference between quad-tree and octree is the dimensional and the octree. Quad-tree partitions a two-dimensional space divided it into four quadrants, where octree partitions a three-dimensional space dividing it into eight quadrants. Number 2, number of children. In quad-tree, X node has maximum of 4 children corresponding to the 4 quadrants. And octree, X node has maximum of 8 children corresponding to the 8 quadrants. Number 3, memory over memory. Octree generally requires. Number 3, memory over memory. Octree generally requires more memory compared to quad-tree due to the additional deletions and subdivisions. The octree nodes contain more data and require more memory allocation, resulting in higher memory overload. Similarities. Tree structure both quad-tree and octree follow a hierarchical tree structure. Each node, the tree represents a region or volume in space, and the subdivisions are represented by the channels. Number 2, structure partitioning. Both data structure partitions the space with QCAD. The space is divided into smaller regions of volumes based on the distribution of data points, allowing for efficient spatial indexing and integrity. Number 3, dynamic data insertion. Quad-tree and octree support efficient insertion and deletion of data point within the data insertion. Quad-tree and octree support efficient insertion and deletion of data point within the structure. The tree structure dynamically adjusts for accommodate queries that involve searching for points or subject within a specified rectangular region or volume. They reduce